Well, hey there, kiddos. We're going to talk about exponential growth and decay today, which is just what we've been doing, only we're going to talk about increasing functions and decreasing functions, and everything that we do is going to increase or decrease by a certain rate. And so it's a growth and decay function. You get to learn a new equation today. Do not worry, you don't have to memorize it, but you do need to have it written down in your notes so that you can see it. The first thing we're going to do is something that's going to help you with the second half of your M&M activity tomorrow. We have data in a table that shows the relationship between the value of a car and how old the car is. We are going to use this table. We're going to plot the points, make a scatter plot in our calculator so we can look at it, and then we're going to calculate the equation based on the type of graph. That's why this window thing is here. So we're going to have to type these numbers into our calculator. So we're going to go to our calculator over here, and we're going to go to Stat and Edit. And then we're going to put the car's age into list 1 and the value of the car into list 2. So I have 0, 1, 2, 3, and 4. Then over here in list 2, I'll go ahead and put the values. So I have 20,000. And then 17,000, and then 14,450, and then $12,282.50, and then 10,440. And you see that my calculator took the one with the decimal and it rounded it up to the next highest thing. It's because there's not enough room for that number, so they went ahead and rounded it up. It's fine, it's not a big deal. So we're going to set our window on our table based on what's in that graph. And so in our table here, my car's age, which is the x values, goes from 0 to 4. And so if I want to set my window for that, then my minimum needs to be a little less than 0, so I'm going to say -1. My maximum needs to be a little more than 4, so let's go with 5. And since I'm just going from -1 to 5, I can count by ones. Here's the problem here with my y values. My smallest value here is 10,440, so I'm going to make my y minimum 10,000 so that it's a little bit smaller than that. My biggest number over here is 20,000, and so I need a number bigger than that, so let's go with 21,000. And since I'm going from 10,000 to 21,000, I need my scale not to be ones, because I don't want to go 10,000, 10,001, 10,002, all the way up to 21,000. That would take all day. So let's make our y scale 500. That way it goes by 500s instead of by ones to get it. And so we're going to graph that. We're going to type that into our calculator. So my x minimum was -1, and my x max was 5. We left the scale alone. My y minimum was 10,000, and my y maximum was 21,000 with a scale of 500. You don't have to worry about this other stuff. We're going to graph this, but what I want is the scatter plot. So instead of just pressing graph, because I haven't put anything in y equals, I'm going to go to second y equals. I'm going to turn this first plot on, so I'm going to hit enter, and this right here is blinking on, so I'm going to hit enter so that it's highlighted. Everything else should be good. Now before I graph, I'm going to go to y equals, and I'm going to clear out any equations that are there so that they do not graph on top of my scatter plot. And so then I press graph, and I should get this scatter plot. And so I have this scatter plot, and it sort of looks like it's going in a straight line, but it's really not. This is going to sort of curve. Okay, and I know that it's going to sort of curve because these are getting smaller and smaller and smaller, but if you think about it, you're talking about the value of a car, it's never really going to equal 0. So we want to calculate the equation. We're going to say this is an exponential equation, so I'm going to go to Stat and over to Calculate, and this time, because I'm dealing with an exponential, I want to be able to do a regression for exponentials. Well, it's not on my screen, so I'm going to have to scroll down. And if you'll see, 0 here is exponential regression. So I want to do option 0. And you're going to go down until it says calculate. Hit enter. It will give you the equation. And it's going to put it in the a times b to the x format. And we're going to round. We're going to call a 20,000. And we're going to call b 0.85. And so what I have is 20,000 times 0.85 to the power of x. And so that's what's happening. There's my equation. And then it says John likes to keep all his cars for 10 years. We want to know the value of the car after 10 years. That's when we go back to our calculator. We go into y equals, and we're going to enter that equation we just wrote down, which was 20,000 times, 0.85 to the power of x. And we go to our table, second graph, and I need 10 years, and so we'll go to where x equals 10. And so here x equals 10, and so I have that the value of the car is $3,937.50. So the value of my car after 10 years is $3,937.50. That's the value of my car. Now, will the value of the car ever equal 0? No, it shouldn't, because this is an exponential function and it just keeps decreasing and decreasing. It will never actually hit 0. And if you think about it, it's very rare that a car is actually worth nothing at all. Even if it is completely totaled and wrecked, there's a value to it. The insurance company will assign a value and they will pay for that part. That's why it's totaled. Okay, sell it to a junkyard, it's still worth something. The parts are always worth something. It's not going to reach 0. So that's an exponential regression. That's how you'll do that when you get asked that question tomorrow for your M&M activity. Go to stat plot, put it in, and then go find the graph. Now, exponential growth and exponential decay are two different types of exponential graphs. Growth obviously increases, decay decreases, and it's always because whatever you're doing is increasing or decreasing by a certain rate. We're going to see problems in just a minute, but there's an equation associated with exponential growth. It looks like this. It is y equals a, which is the same thing as the a in the original problem. It's going to be your y-intercept, and then it's going to be 1 plus r to the power of t. Your exponential decay, if it is decreasing, is a times 1 minus r to the power of t. Now, what does everything stand for? A is your initial amount. It's going to be your y-intercept. So whatever your y-intercept is, that's going to be your a. Your r is going to be the rate at which whatever you're dealing with is increasing or decreasing. It needs to be in decimal form. And then t is the amount of time that you were dealing with. And so it's just going to be a matter of plugging numbers in. So for this first problem, exponential growth. So the population of a city is increasing at a rate of 4% each year. The fact that its population is increasing at a 4% rate, that tells me exponential growth. A rate of 4%, exponential growth. In 2000, there were 236 people in the city. Write the exponential growth function to model the situation and then find the population in 2009. Well, we got to find out what A and R are first of all. A is the initial amount. Well, we're going to assume that 2000 is where we started, so the initial amount is 236,000. Your R for this problem is 4%. Well, I can't use it as a percentage. I have to turn that into a decimal, which happens to be 0.04. So now I have my A and my R. So I'm going to substitute those in. So I now have y equals 236,000 times 1 plus, because it's an increasing that makes it growth, 0.4 to the power of t. Now we're supposed to find the population in 2009. Well, from 2000 to 2009 is 9 years. That's going to make t 9. So if t equals 9, I'm going to take that same equation I just wrote down, I'm going to plug in t, and I'm going to find out, or 9, and I'm going to find out what it equals. So I have y equals 236,000. I'm going to shortcut this. 1 plus 0.04 is 1.04. There's no reason to keep the plus sign in there. I can combine those to the 9th power. Okay? Now it's just a matter of grabbing your calculator and typing that in. So I have 236,000 times 1.04 to the power of 9. I want to know what the population was then. There it is, and we're going to round this to the nearest person because we're dealing with population, so it looks like it was 335,902 because that's going to round that to a 2. So I have 335,902 people in 2009. So now let's talk about decay. It's a very similar kind of problem, but now you have stuff that's decreasing instead of increasing. So the population of a city is decreasing at a rate of 6% each year. That's kind of not good. You don't want your population to decrease. Your town will disappear. So it's decreasing at a rate of 6% each year. In 2000, there were 35,000 people. We want the exponential decay function, and then we want to find the population in 2012. Well, A for this problem is where we started, which was 35,000. My rate for this problem is 6%, and just like before, that needs to be a decimal, so 0.06. And then we're going to substitute in, so I have y equals 35,000 times 1, and this time it's minus 0.06 because you're decreasing to the power of t. Well, if I want to find the population in 2012, from 2000 to 2012 is 12 years, so t is 12. So my problem is going to be y equals 35,000. We're going to simplify this. 1 minus 0.06 is going to be 0.94 to the 12th power. Grab your calculator. 35,000 times 0.94 to the power of 12. So in 2012, the population of that town is now 16,657 people. It doesn't round, so we have 16,657 people. So this one is increasing, this one is decreasing. And what makes it exponential is that it is increasing or decreasing at a rate, not just, by 3 or 4 or 5. It's a percentage. It's going to be a rate. So let's flip over to the back. Let's do a couple more problems. So we'll do number 5 here. And take that back. We'll do number 4. Number of sport radio stations has increased at an average of 14.3% per year. If there were 220 sports radio stations in 98, approximately how many would there be in 2013? So here's our rate. So I have y equals, A is my starting value, which is 220. Then it's increasing, so it's 1 plus, and 14.3%, you move your decimal, becomes 0.143. So it's 0.143 to the power of t. Now we'll deal with what t is in just a second. We're going to simplify. So y equals 220 times 1.143. And from 98 to 2013 is 15 years. So we'll type that in our calculator. 220 times 1.143 to the power of 15. Looks like there will be 1,633 radio stations. So there should be about 1,633 radio stations in 2013. Sports radio stations. Number 5 is the same kind of problem. Internet chat room has 1,200 participants and is increasing at a rate of 2% per year. How many will there be in 5 years? Well, starting amount is 1,200. It's a increase, so it's growth, so it's 1 plus 2%, which is 0.02. And I want that over 5 years, so I have 1,200 times 1.02 to the 5th power. So 1,200 times 1.02 to the 5th power. There will be about 1,325 people in chat rooms in 5 years. Now number 6 just asks you to find the equation of the function shown in the table. This is where we're going to grab our calculator, we're going to go stat edit, and then we're going to do the exponential regression. And so it's going to be the same thing. We're going to enter these values into our calculator. So we're going to go to stat and edit. And then over here in list 1, we'll clear out what was there because we put stuff in there. And so we're going to enter in the ones we have. We have -3. And then we have 1, 3, 4, and 8. And then over here in list 2, we will put our other numbers. And so we have 0.001, 0.625, 15.625, 78.125, and 48,828. That doesn't even have a decimal. Okay, they're asking us for the function rule. I'm going to assume that since these numbers are getting really big really fast, that's going to be exponential. We're going to go stat, calc. It was option number 0 for exponential regression. Go down here to calculate, hit enter, and so it's going to spit it out for us. and we're going to round this. We're going to call this 0.125, and we're going to call this 5. So my equation is going to be 0.125 times, wrong number, 5 to the power of x. That should be your function rule. And it's not exact, but it's close enough. Okay, so here is the function rule that goes with that. I just did an exponential regression to get it. Practice this when we get here tomorrow. I will see you then.